Good morning, guys. Today I'm going to give a lecture on friction. It is a topic of engineering mechanics. As you know that which student who are interested on friction, or you can say that engineering mechanics like first year and second year student can have this topic. As you know that this is a toughest topic of engineering mechanics, that is friction. Today I'm going to explain all the small things in friction. This is a first lecture on friction, so continue with it. So first of all, what is friction? Okay, as everyone knows that friction is the contact resistance exerted by one body when second body moves or tends to move past the first body. Okay, like if there is a single body like this, another body is on top. When they slides on each other, a resistance felt by other body, that is called friction. Friction is a retarding force that always acts opposite to the motion or tendency to move. Okay, friction is always act against the body. Okay, it is a key point that you have to keep in mind, that friction always act against the motion. Okay, so a body which is try to be move or it is in motion, there should be a friction. If a body is in static position, I can say that the friction is zero at that time. Okay, now the type of friction. There's different types of friction in which you can carry. First one, that is dry friction. In our engineering mechanics, we will deal with dry friction. As you know that we are dealing with rigid bodies. In engineering mechanics, we are dealing with rigid bodies. When we are talking about other bodies, we are going to assume that is the strength of material and other subject that is related to structure. Okay, this is a basic subject that is related to engineering, that is related to civil engineering or also mechanical engineering. This lecture is useful for civil and mechanical both student. So first topic is dry friction. Dry friction is also called Coulomb friction, occurs when unlubricated surfaces of two solids are in contact and slide or tend to slide from each other. Okay, if lubricant separates these two bodies, the friction created is called lubricated friction. Okay, dry friction, that means two dry bodies. It's like anything like two blocks are resting on each other, or two blocks are resting on a surface, or one block is resting on a surface, a rigid surface. That surface is rough. At that time, you can say that there is a dry friction is active on that body. Okay, another one is fluid friction. Fluid friction is similar. Friction is same for everything. Friction is simply the resistance against the movement. But when we talking about fluids like gases and liquids, okay, when we talking about fluid, at that time the friction act between the particles of fluid, I can say that it is a fluid friction. Okay, fluid friction occurs when layers of two viscous fluids moves at different velocities. Okay, the relative velocities between layers cause frictional force between fluid elements. Thus, no fluid friction occurs when there is no relative velocities. Okay, remember it. If there is no relative velocity, that means the fluid particles are in rest. At that time, you can say that the fluid friction is zero. If you are a second year student, you listen about fluid mechanics. Okay, we are dealing with fluid friction and fluid mechanics. That is, you know that a name by viscosity. Okay, we are dealing with viscosity. That is fluid friction. Okay. Okay. Continue with a different type of friction, that is skin friction. Skin friction, also called frictional drag, is a component of force resisting the motion of solid body through a fluid. Okay, for an example, when aeroplane move in air, at that time you can see that air is a fluid. Okay, an aeroplane is a rigid body, solid body. Okay, solid body move in air. At that time, the friction is generated because it is in movement, and we know that if something is in movement, at that time friction is act on this. Okay, so skin friction is also called a friction drag, is a component of force resisting the motion of solid body through a fluid. Okay, the next one is internal friction. Internal friction is associated with shear deformation of solid materials. subjected to cyclic loading. Okay, first of all, what is cyclic loading? If you are confused with this word, I can say that if something is continuous for a particular time, at that time you can say that it is a cyclic loading. Like 1, 2, 3, 4, 5 kilonewton load are moving in a 6 meter span continuously. It is moving. Okay, at that time I can say that it is a cyclic loading. Okay, in every few minutes that particular span is subjected to some particular load, I can say that it is a cyclic loading. Okay, so internal friction is associated with shear deformation. What is shear deformation? If a body is, I can explain this with just a minute. Okay, like if this is a body, okay, this body is resting on particular surface, that is rough surface. I assume a rough surface because a friction is generated on rough surface. If I am talking about shear deformation, I can say that this body is deformed like this in some angle. If a body is deformed in some angle, I can say that this is a shear deformation. Okay, I hope so you are able to understand this. If body is deformed in some angle, particles of body is deformed in some angle, at that time I can say that this is a shear deformation. Okay, so continue with this internal friction. Internal friction is associated with shear deformation of solid materials subjected to cyclic loading. As deformation undergo during loading, internal friction may accompany this deformation. Okay, now these are the different types of friction that is act on different modes. Now we come to the dry friction, as we are dealing with engineering mechanics, and you know that engineering mechanics is deal with rigid bodies, and rigid bodies are subjected to dry friction. Okay, so continue with dry friction. The element that we need to understand in dry friction, that is N. N is nothing, it is a reaction force. When I want to make a FBD. FBD is what? Free body diagram. Okay, if I want to make a free body diagram of this particular body, that is the load of this body is W. At that time, how can I explain this? A body, there is a body, you can see that this is a body. If I want to make a FBD of this body, free body diagram of this body, free body diagram is nothing, it is simply a body in which all the forces are acting. When you cut in particular manner, you can cut in any manner. Okay, now you can see that if I'm making the free body diagram of this particular body, I have to remove this surface. Okay, because I'm making the free body diagram of this particular body. If I'm making the free body diagram of surface, then it is indifferent member. I can make both. Okay, like this is a surface. Okay, a free body diagram of surface. Even we never need this, but for your understanding, I will explain both. Okay, so this is a body. I want to make a free body diagram of this particular body. If I remove this particular surface, there is a reaction force here. Okay, so I'm applying a reaction force due to this surface, that is N. So, our first unknown is N, total reaction perpendicular to the contact surface. Okay, that is N. When I remove this surface, this N is acting on the body. Okay, I know that if I'm talking about friction, that means it is compulsory that this body is trying to move. Okay, if this body is trying to move on particular direction, or this body is in moving condition. Okay, if it is in moving condition, the coefficient of friction is mu k. Mu k is what? If the body in static condition, this is subjected to mu s. Mu s is nothing, it is a static coefficient of friction. Okay, if this body is tend to move, at that time also we apply mu s. Okay, but if this body is in moving condition, at that time this is a kinetic coefficient of friction, that is mu k. If there is a relation in between this, we can deal with further. And F is what? The second word is friction. Okay, second friction force, F. If I remove this surface, and this surface is rough surface, okay, if this is a rough surface, at that time a friction force should be act on this, okay, a parallel force that is resisting the movement, that is frictional force acting on this particular body. And we know that this friction force is acting on opposite to the movement, okay, opposite to the direction of movement. If I'm seeing this body, I can say that this body should be moved in forward direction. Is it? Why? Because our external force is acting on outward direction. So this body should be moving outward direction. If this body is moving forward direction, that means friction force should be acting backward direction. Okay. So our frictional force is moving in backward direction. Okay. Now, the body should have some weight, okay, that is always tend to gravity. So I can say that the weight is acting on downward direction, that is W, body weight, okay. And external force is acting on this particular body to move this in forward direction, that is F, okay. It is acting in some angle. It may be alpha, beta, anything you can assume. Further we will find it. Okay. So this is our FBD, free body diagram of this particular body. Okay. So now you're confused with what is R. Okay. So R is nothing. It is a resultant force in between reaction force and frictional force. Okay. As you can find it like this is R, a resultant force. Okay. In between N and F. This should be acting in some angle that you need to find out, that is phi. This phi angle, we know that it is an angle of friction. Okay, we have a lot of theory behind this, so we further discuss it. So this is an angle of friction phi. This is a resultant force that is act between N and F. F is external force, W is downward force. Any other force act on this body? No. So I can say that this is a final diagram, it's final FBD of this particular body. Okay. Now, if I want to make a FBD of this surface, okay, then what I can do? This body is acting on this, so I can say that there should be some reaction for this body, okay, and this have some movement in this direction, so I can say that friction is act on this. As I said that we don't require this, but if I want to make it, at that time we need to introduce this surface to two forces. One is frictional force, another is reaction component. Okay, two component are come at where frictional forces act. One is frictional force, another is contact reaction. Okay. So these are the basic keys word that is used in frictional force. Now further come to the what is frictional force. Okay, before this we read what is friction. Now we well known with frictional force. Now we come to what is frictional force. Okay, what is frictional force? It is introduced with F, and frictional force is directly proportional to the reaction, contact reaction. Okay, frictional force is nothing, it is directly proportional to this resistance, contact resistance. Okay, so F is directly proportional to N. I can see that F is directly proportional to N. Okay, if I remove this proportional at that time, I can say that this is equal to mu N. Okay, then what is mu? Mu is nothing, it is a coefficient of friction, okay, which come when we remove this proportional. So F is equal to mu N, that is your first formula that is used in frictional force equations. Now further, if I want to find out this phi, okay, if I want to find out the angle of friction, phi is the angle of friction, I can say that the tan phi is I can find out this by tan phi is equal to mu, coefficient of friction. If tan phi is equal to F by N, then I can find out the F by mu is also F by N. Okay, so both things tan phi is equal to F by N, so I can say that tan phi is equal to mu. Okay, so angle of friction is nothing, it is equal to coefficient of friction. So these three formulas that is used in our friction topic. Okay, continue with other theories behind frictional force. So the block, that is this block is resting on an inclined surface. Okay, this block is resting on an inclined surface. The surface may be inclined, the surface may be plane, horizontal, anything. If this is a rough surface, there should be a frictional force. Okay, so this is an inclined surface in which a body is resting, that is weight W. Okay, this weight W body is resting on this inclined surface. Okay, it may be in rest position, it may be tend to move position, it may be in final movement position. Okay, so how can I find out in which condition this body is right now? Okay, so consider the block shown to the right that weights W. Okay, consider the block shown this, okay, W, and this is resting on an inclined surface that is in angle theta. So first condition, if phi is this, the angle of friction. Okay, first of all we find out the phi we can easily find out with tan inverse mu. If I have mu value is 0.25, at that time I can say that tan inverse 0.25 is equal to phi. Okay, so we can easily find out the value of phi. So if I have a phi value, okay, and this value is also given in our question, inclination of this particular surface should be given in our question. So if phi is less than theta, the maximum available friction force is less than Wx. Of course, if friction angle is less, at that time frictional force is less. If friction angle is higher, then friction force is higher. Okay, so if phi is less than theta, the maximum level friction force F is less than Wx. Thus the block will slide down. Okay, does the block will slide down? Of course. If phi is equal to theta, okay, the condition of movement, okay, the condition of impending movement is what? When the body is trying to move, okay, it just in the position of movement. Okay, when the instant or point at that time the body start to move, okay, that particular point is known as, that particular motion is known as impending motion. Okay, if phi is equal to theta, that means angle of friction is equal to inclination of that particular surface. The frictional force F will just equate to Wx. Thus the block is in impending motion down to the plane. Okay, the last one, if phi is greater than theta, that means angle of friction is greater than the inclination of that particular surface, the maximum available frictional resistance F is greater than, I can say that block is in stationary position. Okay, if frictional force is higher, that means it stop the movement. Okay, if it is started to stop oppose the movement and it is in higher position, I can say that body is stationary, body is in rest. Okay, if frictional force is higher, that means body can't move without any external force. Okay, so if phi is greater than, that means frictional force is greater than. If frictional force is higher, the block is in stationary position. Okay, if friction force is less, that means block should move. Okay, we can therefore conclude that maximum angle theta that a plane may be inclined without causing the body to slide down is equal to the angle of friction. Okay, I hope so you clearly understand what is phi, what is theta, what is F, what is N, what is mu. Okay, so this is the total theory behind the frictional force. Okay, now we will continue with the questions. For question, I suggest that there should be an online site, that is Mathalino. You can find the questions of engineering mechanics in that particular site. This is a parallel surface. Okay, this is our body. This is W. It should be in some angle. The angle should be, if this is theta, then I can say that this is also theta. Okay, so if it is W, I can say that it is W cos theta and this is a W sin theta. Okay, two component of this, Wx and Wy. F is acting on this in opposite to the motion. If this is try to move down, that means friction force is acting upward. Okay, and N resisting, this is a reaction force when we remove this particular surface, and a resultant force should be there, that is R. Okay, so this is the FBD of this particular inclined surface. So if you have any doubt in this to make FBD, you can ask. Continue to the questions. The first question for practice, that is a 400 lb block is resting on a rough horizontal surface. Okay, simple diagram is a 400 lb block is resting on a rough horizontal surface for which coefficient of friction is given. That means I can easily find out the phi also. Tan inverse mu is equal to phi. Okay, determine the force P required to cause motion to impend. Impend, that means it is in position of movement. Okay, if applied to the block, first case is horizontally. Okay, the body is rest horizontally to the surface. Another is body is, the force is acting in first body, in first case the force is acting in horizontal direction. In another case the force is acting in some angle, in the angle is 30 degree. And then the third one, what minimum force is required to start the motion. Okay, there's three questions. Determine the force P required to cause motion if applied block is horizontally, another is in 30 degree with horizontal. The next one is what is minimum force is required to motion. Okay, now come to this. The first case, you can see that a 400 lb block is resting on a horizontal surface. A 400 lb block is resting on a horizontal surface. The surface is rough. Okay, the coefficient of friction that act here in this surface, this is 0.40. The mu value is 0.40 and it is mu s or mu k. It is of course mu s because the body is in a static position right now. Now it is try to move. Okay, so it is this time it is in impending motion. So I can say that the coefficient of friction is static. So mu s is acting on there. So I can say that the 0.40 value is mu s. Okay, if the body is in moving condition, at that time if mu is given, then it is a kinetic friction, it is mu k. Okay, continue. Determine the force P required to cause a motion to impend if applied block is horizontal. Okay, you can see that a force P is act horizontally. Okay, FBD of this particular body is simply a W act downward, a force external P, that is in question. We need to find out a force P is acting on forward direction. So the frictional force is also acting on backward direction. So the F is acting here. If I remove this surface, there should be an N, that is contact surface reaction should be there. Okay, so easily I can say that this is a FBD of 400 lb block. Okay, the first case, all the questions of engineering mechanics is easily solved with if it is in static engineering mechanics, all the question easily solved with equilibrium equations. Okay, what is equilibrium equation? There is three equilibrium equation in 2D condition, 2D two-dimensional condition. There is three equilibrium equation. One is sigma fx, that means frictional force in horizontal direction. Summation of frictional force in horizontal direction is 0. Okay, all the frictional force that is act in horizontal direction is equal to 0. The first equilibrium equation. So I can say that if I apply sigma fh is equal to 0, sigma fh is equal to 0, summation of horizontal forces acting on it, all the forces, it is in forward direction, so P is in plus, it is in backward direction, so F is negative, P minus F. Any other horizontal force is not acting in this body, I can say that P minus F is equal to 0. Okay, if P minus F is equal to 0, I can easily say that P is equal to F. Okay, another equilibrium equation is all summation of vertical forces is equal to 0. Okay, summation of vertical forces is simply 400 lb and N is acting on vertical direction. So 400 lb is downward negative, n is upward positive, n minus 400 is equal to 0, so n is equal to 400. Okay, so n is equal to 400 lb. Okay, now these are the equilibrium equation. The third equilibrium equation is movement, which is not required here. Summation of movement is equal to 0. Okay, so we use sigma fv, we use sigma fh. Okay, further we don't need to use any other equation because there is only single unknown, so I can say that it is solved in two equations only. How many unknowns are there? Number of equation is simply used similar number. Okay, if two unknowns are there, then two equilibrium equation should be used. If three unknowns are there, three equilibrium equation should be enough to solve this question. Okay, so sigma fv is equal to 0, sigma f is equal to 0. I can say that sigma fv n is 400 lb, and by the formulas of friction force, that is F is equal to mu n, I can easily say that F is equal to mu n and n is 400 lb in our first equation. So we put the value of n, mu is already given in our question. So 0.40 multiplied by 400, the F should be 160 lb. Okay, and what we need to find out? The P value. And in sigma fh is equal to 0, I know that P is equal to F, so I can say that P is 160 lb. Okay, so easily, it is very easy to find out the force, impending force. Okay, so this is our first case when force is applied horizontally. Okay, we find out the P at the external force, how much external force is required to make a body in impending position. Okay. Continue with second part. When the force is acting in some angle that is 30 degree. Okay, this force, this external force is acting in 30 degree position. At that time, how much force is required to move this block? Okay, so same, the equilibrium equations are similar, but this time two component of this P should be act. One is in horizontal direction, another in vertical direction. Okay, two components are there. By resolution of forces, you know that what is resolution? Resolution, when we resolve a single force in two component, at that time we making the questions in easy way. Okay, we make a we can make easy question. Okay, so I can break this particular P in two direction. One is horizontal direction, another is vertical direction, the component of P. Okay, summation of vertical forces is equal to 0. Again we apply vertical forces. One is n, another is 400. N is positive upward, 400 is negative downward, and P is also in negative direction because it is also downward. You can see that the component, this is inward, this is downward. Okay, so vertical is downward and horizontal is inward. Okay, so this is also acting downward. Summation of vertical forces is equal to 0. I can say that n is equal to, these are in same condition, so 400 plus P sine component sine 30. Okay, so first equation is n is equal to 400 plus P sine 30. Can easily understand. Okay, again we know that if n is this, then F is equal to mu n. We can put the value. The F is 160 plus 0.2 P. Okay, this is, now we can't solve this further, so I can say that this is an equation. We make it equation and apply another equation. Okay, another equation, summation of horizontal forces is equal to 0. Horizontal force, this friction force is in horizontal direction, this horizontal component of P is in horizontal direction. P cos 30 minus F is equal to 0, so I can easily say that P cos 30 is equal to F. Okay, P cos 30 is equal to F. F is already, we find out 160 plus 0.2 P, we put it. Now we can easily find out the value of P. So I hope so. It is very easy. The questions of friction force is very easy. Okay, this is a basic type of question that is generated in frictional force. Okay, next one. One more thing, this question can be solved in other manner also. that is another theorem, that is Lami's theorem. Okay, in my next lecture I can explain what is Lami's theorem, and I can solve this question with Lami's help. Okay, so for today it is enough. Okay, we will continue with this question. The end of this question, the part C, minimum force required to cause impending motion. Okay, the minimum force, the third C part of this question, find the minimum force required to cause impending motion. Okay, now this body, similar body, 400 lb, the reaction force NF is in opposite direction of moving direction. Okay, now P is acting in some angle. We need to find out this angle and this P, and this P is minimum force. If some force is minimum or maximum, at that time we uses the 12th standard chapter, that is maxima minima. Okay, to make any body in minimum position or least position, I can simply differentiate this force with some angle. Okay, so the same sigma Fv is equal to 0, summation of vertical forces, all the vertical forces, the vertical component of this in upward direction, so it is minus, again F is equal to mu n, put the value, the equation is this. Similarly as above, sigma Fh, similarly we solve, we find out this P. Okay, but now you get confused, how can I solve this, because there's two unknown, one is P, another is alpha. Okay, if we need to find out these two unknowns, there is a equation, we need to find out a minimum force. Okay, there is a condition, we need to find out a minimum force. Whenever we need to find out a minimum or maximum force, at that time maximum minima equations are used, Magnus theorems are used. So to make any load or anything its minimum condition, differentiate it with some angle and make it 0. So if after this condition, whatever P we required, whatever alpha we get, this alpha is minimum inclination of forces. So at that time the minimum P is, we can find out. Okay, so dP upon d alpha we can easily differentiate all the equations. Differentiation is very easy for engineering student. Okay, so dP upon d alpha, make it sin alpha, we can easily find out the alpha value, and this alpha value we need to put on this particular P, and whatever P is get by this P is minimum force that is required to move a body. Okay, so this is my first lecture on friction. I hope so you get it. Thank you so much for listening me very patiently.